So today we are going to talk about the topic called electric vehicle architectures and components. Um, so what are all the different architectures we follow for various applications? So we have two-wheeler, we have four-wheeler, and bus applications, car applications. So we are going to see all those things. And what are the various components that are available, that are present in the electric vehicle? So those things we are going to cover today. And this is my email ID. You can have a note of it. P.Arjunraj@gmail.com. And I can also be contacted at 8778983428. So let us go for the session, electric vehicle architectures and components. So why we are going for an electric vehicle? The adaptation of the electric vehicle in private and commercial passenger vehicle is seen a way forward for decreasing the greenhouse gas emission and also to reduce the pollution basically, and which will have a solution for the climatic change problems. And the use of IC engines, internal combustion engines, uh, the way forward what we have reached is almost 35 percentage. And but still it is a bit less that battery operated electric vehicle, which is around 65 percentage. Hence, among all these efforts and initiatives, the move forward is for electrification, for the way forward, basically for a long-term solution in order to address the transportation problem and the pollution problem and the greenhouse gas effect, the change problem. So the solution here is to go for electric vehicle, and the vehicle, the number of vehicles is also getting increased day by day, and the population across the globe is also too high, and the earning potential of the people across the country is also getting increased because of the globalization, and as a result of that, commuting opportunities is also too high for the people to go to various places. It can be going for a shopping or going for an office work, going for some travel occasion. So because of the globalization, what I can say is it is playing a way forward, one for an advantageous kind of thing where people are getting a good opportunity for their job. On the other hand, because of the increase in the commutation and also the traveling opportunities, we are also paying a way forward for the pollution issues or increasing the pollution problem. And also it will also create a great setback for climatic change, especially the greenhouse gas emission. So in order to address all those things, it's very important that we need to have a, a green fuel, which is basically an electric vehicle. So here we are going to see various aspects, basically with respect to the architecture and also the components. So let us see some key parameters with respect to design, modeling, and simulation of an electric vehicle. Um, so there are a lot of new designs are coming up in order to meet the demand of the architecture and also to meet the challenges of the future vehicle technologies. And whatever the structure or the architecture what you are going to have, it needs to be flexible enough so that it can adopt the various components, especially the drivetrain. It can adapt it very easily, quickly, without affecting the existing platforms. And the other heart of any vehicle, okay, is first one is going to be the design, the next one is going to be the modulation and simulation. So when designing the architecture of any electric vehicle, it is mandated that you are going to use some of the softwares related to modeling and simulation. You are going to concentrate on the various verticals like electric powertrain verticals or battery verticals or power electronic verticals or electric motor vehicles verticals, sensors and control systems. We are going to consider all these things when you are going for modeling activities or for a simulation activities, especially for a new design basically. These are some of the characteristics of an electric vehicle. So the electric vehicle must have one or more electric machines, and the electric vehicle should also have an energy storage system, shortly called as ESS, apart from what we call as a fossil fuel tank. And electric machine, shortly called as EM, it must provide the propulsion power. It can be either partially or fully. And these three are the main characteristics of an electric vehicle. And you have various types of the electric vehicle. You have micro hybrid electric vehicle, mild hybrid electric vehicle, full hybrid electric vehicle, and plug-in hybrid electric vehicles. So you have various types in itself. Let us see what are the various types of hybridization that has taken place over the years. So you call this as a degree of degrees of hybridization. As I said in the previous slide, we are going to have various types of electric vehicle with respect to hybridization, like micro hybrid, mild hybrid, full hybrid, and also the plug-in hybrid. When it comes to the micro hybrid, you would have seen a vehicle C3 Citrian, where you have automatic start-stop engine technology, where it is being used for traffic application. And you have the mild hybrid application, where this is applicable for a Honda Insight vehicle, in which you have start-stop technology, and also you are going to use the regenerative braking, and it's going to operate above 60 volts. And you're also going to have, you're also going to use an electric motor to assist and combustion engine. Okay. And the next one is going to be a full hybrid. In addition to the start-stop technology, regenerative braking technology, and also to the electric motor technology, what you're going to use is it's completely full of hybrid application, where it can also drive at times using only the electric motor also. Okay. So when the charge is going to be completely occupied, or when it is going to be completely over, then you can switch it to the IC engine mode. The last one is a very interesting called plug-in hybrid, where you have all the features, including the recharging batteries from an wall outlet for an extended electric range also. So the example of the full hybrid can be Toyota Prius vehicle, and for the plug-in hybrid vehicle, you have the application where it has been used in Chevy Volt vehicle. And the efficiency gets increased as the level of hybridization is getting increased basically. So these are all the key attributes that you need to consider when you're going for a design of electric vehicle. First one is going to be the power delivery part for the components that uses other than the electrical system. Well, power delivery part should be continuous, and there should not be any obstructions, especially when you are going for the mechanical components like brakes, suspensions, steering, and cooling systems. And you also have the important attributes, the electrical power demand of various subsystems like the infotainment systems, power window systems, and also the AC systems. And the other attribute is the drive cycle based torque and the drive cycle based power requirements for all operating modes. You're going to operate the vehicle in different modes. Okay, it can be in city condition mode, or it can be the highway application, or it can be in a normal mode, or in sports mode, or in hyper mode. You have various different modes which the different vehicle manufacturer will be giving for a different vehicle applications. The key attributes that electric vehicles have is that manufacturers should ensure that irrespective of the modes what the customer is going to use, they need to ensure that the drive cycle based torque and the drive cycle based power requirements is going to meet all their operating modes for the customer. And the next one is the overall energy supply and also the management, which includes the charging and regeneration capability utilization. That is one of the important key attributes. And then the specification for the products, the technical specifications, for example, the charging, quick charging. You also have various standards for it, uh, and also you also have the various um, improvement areas as well to increase the drive cycle efficiency and also uh, power and torque aspect. So how the electric vehicles should also interact with the external world, say for example the communication aspects or bi-directional power transfer. So those things are also very much important with respect to the electric vehicle components. And also, you know, the fuel cells, batteries, and its combination is going to play a vital role for the energy sources. And the another important key attributes of an electric vehicle is to have an adaptation for different energy sources for its operations. And the electric vehicle should have the considerable weight scenario. It should not have too much weight, because the too much weight will also create a range problem, and should have the optimum weight basically, considering the various parts like battery, traction system, and air compressor, etc. And a very important thing that the countries like the Asians basically, Asian countries are most cost and reliability oriented. In order to meet this, the selection of the battery is very much important. So currently, we are going with a lithium ion battery. A way forward for it means when the way backward, I can say 10 years back, we were using a lead acid battery. The weight of the lead acid battery is almost 3 times higher than that of what we are using currently. It's lithium ion based battery. Um, Even though the cost is slightly higher, but again the reliability is much more better. So we need to have some target where we are going to meet both cost and reliability for the technologies that we are going to use for the electric vehicle. It can be not only for a battery, even for a charging application, or for a battery management system application, or for any of the mechanical part what we have seen previously, like brake, suspension, or uh, the vehicle or wheel aspects. So irrespective of that, any mechanical or electrical electronics components, cost and reliability is very much important, and the integration of these parts is also very much important to ensure that the overall cost is going to be lesser, and the reliability of the vehicle, reliability of the components basically. So once if the components is going to be reliable, then the overall vehicle will be reliable. And the very important aspects, the key attributes that we need to consider is safety related parameters. Um, where, for example, we are going to use dual energy sources while we are powering the auxiliary battery. Uh, in the case of BMS, in the case of traction control systems, and also vehicle safety systems. We also have the various vehicle safety related systems for a car application, like airbag, seat belt, the active safety system, and also passive safety system. So you also have anti-lock braking system, and which is an active safety system. So The key attributes when you're going for a design of any electric vehicle is you need to consider all these aspects as well. And the very important thing is the communication system layer, like the CAN network for the inter-ECU communication, and also the gateways for the communication with the external world, and the charging infrastructures. And very important is the wiring harness and displacement. So you have a lot of high voltage and low voltage system and its routings in an electric vehicle. So these are all the various key attributes that you need to consider when you're going for architecture and also for a design of any electric vehicle. So these are all the various types of electric vehicle, um, where we have a hybrid electric vehicle, plug-in hybrid electric vehicle, and battery electric vehicle. And the hybrid electric, as the name indicates, it's going to use both internal combustion engine and also the electric motor. And the application can be between 6 to 12 kilowatt hour. And even the same plug-in hybrid electric vehicle, it can be applicable for a range between 6 to 12 kilowatt hour. It also uses the electric motor and also the battery. When you are using the electric motor application with the help of the battery, in case if the battery is completely getting drained out, or if the state of charge is less than 5%, then you can switch it to an IC engine mode, and the range what we are going to experience in the case of plug-in hybrid electric vehicle when compared to that of hybrid electric vehicle, it can be much more higher, even for a battery related range also. And the last one is going to be pure battery electric vehicle, where we are not going to use any internal combustion engine, where we are going to get 100% electricity from the grid. Uh, Whereas in the previous cases, you can get the electricity from the grid, and also the fuel you can use it as a gasoline. And hybrid electric vehicle, it can have the various combinations. It can be either a series hybrid electric vehicle, or it can be a parallel hybrid electric vehicle, or it can be a series parallel hybrid electric vehicle. Uh, so when it comes for a hybrid, it uses a series drivetrain. Basically, when it goes for a series hybrid, it uses a drivetrain only to receive the mechanical power from the electric motor, or a gasoline powered generator. In case of the parallel hybrid powered drivetrain, basically the electric motor and the IC engines, it can provide a mechanical power simultaneously. And you have one more application where you have a serious parallel hybrid electric vehicle, where the power split device is being used to split accordingly between the motor and also to the generator. And the advantages of the series and parallel is combinedly taken care in the case of the series parallel hybrid electric vehicle. Okay. Uh, the battery electric vehicle, which is also called as BEV, it run entirely purely onto the technology with the help of only battery powered electric drivetrain. And you're going to use the electricity to drive the motor, to drive the vehicle basically, in the form of you have the battery pack, which can be charged by plugging into the electricity grid. And the charged battery pack will also provide power to one or more electric motors. So, so you have the number of electric motors can also be uh, higher or lower depending upon the vehicle category you are going to use. If it is a two-wheeler, you can have a single electric motor. If it is a four-wheeler, you need to have uh, the number of motors will be more. You can have four motors, and also you can, depending upon the size of the motor, also you can increase and decrease accordingly to run the electric vehicle. So Comes for the battery electric vehicles. The main components involves electric motor, inverter, battery, control module, and then the drivetrain. How you have to see the working principle of battery electric vehicle. So the power from the electric motor is converted from the DC battery to AC. The output of the battery is going to be the form of DC, and the DC is converted to AC, and AC is an input, which is a power which is going to the electric motor to run the vehicle. And as you know, as the accelerator is pressed, a signal is sent to the controller, and the controller adjusts the speed of the vehicle by changing the frequency of the AC power from the inverter to the motor. Inverter, the function is to convert the DC to AC. So the output of the battery, as I said, is going to be DC. So to convert the DC to AC, you need to have an inverter, and and inverter is placed between the battery and also the motor, so that you will have the AC power uh, uh, for the which is an input for an electric motor. And the motor then connects and leads to the turning of the wheel through a cog. And when you're going to apply the brakes, you are also going to see uh, you are also going to see that you are also going to have some of the technology called regenerative braking technology, where at the time of applying brake, the mechanical energy is converted to electric energy, and that electric energy is being used for charging the battery. Okay, and these are some of the examples of a battery electric vehicle, like MG Motors, Jetters, uh, and Tata Nexon, Tata Tigor, Mahindra U2O Plus, and Hyundai Kona and Mahindra Verito. So these are some of the examples of the battery electric vehicles. And hybrid electric vehicles, as I said previously, it is going to have both the engine and also the battery. So the heart of the electric vehicle is going to be the battery system, and the heart of the internal combustion engine is going to be the engines. Uh, the source, what is the source for an engine is going to be the fuel, and the source for an electric motor is going to be from the battery. And this hybrid electric vehicle is also being categorized as various types, which we have seen in the previous slides. And it is going to use both engine and the electric motor. And the engine gets fuel or energy from the fuel, and the motor gets an electricity, uh, which is a source of energy from the battery. And the transmission is rotated simultaneously. The drivetrain, what we call basically the transmission, where we have the gearbox, is been rotated simultaneously with the help of by both engine and also electric motor. Then it drives the wheel. And next comes the what are the main components of the hybrid electric vehicle. As I said, for a pure battery electric vehicle, we are going to have the electric motor, battery pack with controller, inverter, and also control module. With respect to hybrid, you are also going to have the engine and also the fuel tank. And what is the working principle of the hybrid electric vehicle? So when I say the hybrid electric vehicle, we will have the fuel tank which supplies the energy to the engine, like what we have for a regular car, and the batteries run on an electric motor. So you can have both the engine and the electric motor, which can turn the transmission at the same time as well. And these are some of the examples where you go with the hybrid electric vehicle with the help of engine application, the help of the electric motor and the electric battery application, along with inverter, controller, and the fuel tank, and the control module. So these are some of the aspects with respect to the hybrid electric vehicle. The upcoming topic, which the vehicle manufacturer is also looking, is the plug-in hybrid electric vehicle, where you have the technique here used is, because of plug-in hybrid electric vehicle, is a series hybrid electric vehicle, where you have both engine and motor, It's been connected series in series, and you can also choose the fuels, conventional fuel, which it can be either petrol or biodiesel, or even go for some other alternate fuels, where you are going to use diesel along with some of the vegetable oils as well, and you're going to reduce. This biodiesel is also a good alternative for reducing the environmental pollution, basically. And it can also be and this PHEV, called as plug-in hybrid electric vehicle, it can also be powered by a rechargeable battery pack. Battery can also be charged externally. To find out more about, you can also click some of the aspects, like say, for example, it can run in two modes. As I said previously, first mode can be an electric mode, in which the motor and battery provide all the energy for required for a car. And next can be a hybrid mode, where in which both the electricity and either petrol or diesel is being employed for this activity. And the part also remains same what we have seen previously. There is no change in the part. And here, let us see the working principle of the plug-in hybrid electric vehicles. Plug-in hybrid electric vehicle get started up in all electric mode and make use of electricity until their battery pack is been depleted. Once the battery gets drained, the engine takes over and the vehicle operates as a conventional and non-plug-in hybrid. That is what I have told in the uh, initial itself. As long as you have the battery, you are going to run it, and once the battery gets drained, you are going to shift it to uh, you're going to shift it to uh, you're going to shift it to the engine application. And this plug-in hybrid can also be charged by plugging it with the help of an electric power source, or even you can use the regenerative braking technologies, which means when brakes are applied, the electric motor will act as a generator. And they said mechanical energy is going to convert to electric energy when you are going for a regenerative braking, and that will be useful for you to recharge the battery, or used for charging the battery. And when you're going for the plug-in hybrid electric vehicle, the engine power is supplemented by the electric motor, and as a result of that, even a smaller engine can also be used. It's not necessary you need to go for a high powered engine. Even if you can go for a smaller capacity or the power rating of the engine, uh, and it will also increase the overall fuel efficiency without compromising on the performance of the vehicle. There are a lot of examples which is being used by various vehicle manufacturers to the plug-in hybrid electric vehicle technology. For example, Porsche Cayenne SE hybrid version is the most known plug-in hybrid electric vehicle uh, across the globe. BMW 330E and Fiat 500E is also a quite uh, good PHEV, and used across many customers across the globe. Hyundai Sonata is quite good in India, and Kia Optima, Volvo XC90 T8 version. These are some of the examples of plug-in hybrid electric vehicles that are running in India and also across the globe. When it comes to the electric vehicle architecture, so you need to have the mechanical aspects, electrical aspects, and thermal aspects. Going to integrate all these, uh, where you're going to have a complete electrical system connecting the charging point to to the electric vehicle battery, and all this needs to be integrated such a way it is going to have high efficiency. Same time, it's going to increase the overall performance of the vehicle. In the current scenario, you need to have the vehicle control strategies to control the traction. When I say control traction, it's not only the battery traction control system, but also the regenerative system as well. And you also have the body control system, chassis control system. You have onboard, offboard charging control system. You have BMS system. You have auxiliary battery power system, and you also have some of the communication network, and you also have the various safety vehicle safety related aspects. So you need to have strategies for all these components as a whole. You call this as a vehicle control strategies. And the next one is going to be the electric architecture and design approach. So due to the increasing complexity and issues which has been arising through various advanced control features, there are a lot of advanced features in an electric vehicle, such as you have as a DC-DC connector or a contactor. So when it is a bidirectional power flow, and this also helps for some of the super quick charging capabilities of battery. And the workflow needs to be adapted to a system of system design support. So you need to have a workflow. Basically, the integration of, when I say the workflow, it is nothing but the integration of the parts. How the battery is connected to the motor through an inverter or DC-DC converter or a connector, or you have the integration between the charging from the grid to the vehicle. The workflow should be adapted such a way, uh, and according to that workflow, you need to also have a high end of design approach, so that the workflow is not going to get interpreted, or it's not going to get stopped by any of the means. These are some of the critical key components with functional description of each component. Um, so you have AC onboard charger, where you have the onboard charging control, outboard charging control, and also the auxiliary system management. With respect to outboard charger, you have the traction control, and you have the user input management and regenerative control system. And that when it comes for the traction and motor controller, uh, so you have the BMS, you have the electrical management system, safety monitoring. You also have the battery control system, battery temperature control. This will control the temperature. If the battery temperature is going to be higher, then it gives alarm, and even the vehicle gets shut down. Uh, Basically, this is used for a safety application. But, data system, what we're going to use a pure battery system, where this will help for reducing the temperature by going for a thermal management system, where we're going for cooling applications in the case of car application, or in the case of bus application. Um, and you have also the energy management system, which needs to be carefully controlled such a way the overall architecture gets improved. And you also have the interaction with respect to the HVAC system, auxiliary system, traction cooling system, and also battery cooling system. You can see there are other aspects like electric vehicle driver display. You also have the compressor, you have the steering pump. As I said, apart from the battery management system or the motor control system, you also have the, the vehicle control strategies. Also involves the body system, chassis system, communication system, etc. And as I said, initially you have two type of cables junctions, basically high voltage cable and also the low voltage cable. And you also have the DC-DC converter, and you have the safety letter monitoring system, which are all the key components for an electric vehicle. These are the electric vehicle components and some of the functions. You can see the various components. First, let us go with alphabetical order. We have the traction battery pack A, and you have this is the traction battery pack, and you have the next one is the inverter B and controller C. Inverter is used to convert the DC to AC. Okay, and once it is converting, and you also have the controller, and you have the electric traction motor. for which the input is going to be the AC power. And the next part is going to be the E part, which is nothing but the onboard charger, which is low, which is inbuilt in the vehicle itself. And the motor drives the drivetrain, which is nothing but a transmission, where the power gets transmitted to the wheel. F F is nothing but a transmission. And then you have the FG is nothing but the DC-DC converter. And H is nothing but the auxiliary battery. So if in case this auxiliary battery is used as an additional battery um, for getting the power or charging the vehicle. And the last one is going to be the thermal cooling system. So unlike in the case of two-wheeler, in the case of four-wheeler, you need to have the thermal cooling system for your for reducing the temperature of your battery, EMS basically. You also have the charging port where you are going to charge the vehicle. So this is going to be the charging port. So how does an electric car work basically? When the car pedal is pressed, then you have the controller called C, which it takes and regulates the electric energy from the battery. You have battery A and inverter is B. So with the control set, the inverter then sends a certain amount of electrical energy to the motor according to the depth of the pressure on the pedal. Then the electric motor, what we have seen is a D, which converts the electric energy into a mechanical energy. Uh, it is transmitting the power to the transmission basically. And then the rotation of the motor is going to take place, which rotates the transmission so that the wheel will turn and then the car moves. This is how the electric car basically works. And these are all the various electric vehicle components. As I said, you are going to have a traction battery pack, power inverter, controller, electric traction motor, charger, transmission, DC-DC converter, battery, thermal cooling system, and also the charge. And these are all the architecture of the electric car, having four subsystems: powertrain system, energy storage system (ESS), and VCS, vehicle control system, and then auxiliary systems. So these are the main four subdivisions or four systems, subsystems, which are part of the architecture of an electric car. And the architecture is very much important, and then you are going to have five important components. And through this component, the powertrain is in a completed shape for an electric vehicle. So you have the electric motor. So this is the electric machine basically, and you have the battery pack, and you have the inverter, and you have the charger, and you have the DC-DC converter. So the inverter converts the DC, which is coming as an output from the battery pack. It converts to an AC, which is used for uh, converting the electric motor to convert the electric energy to mechanical energy. Thereby, it will rotate the transmission gearbox. Gears will be rotating, and finally the final power goes to the wheel. As a result of that, the the movement of the electric vehicle car. And we also have the DC-DC converter where um, this is also an additional thing to maintain the voltage basically. And you have the charger basically. This is inbuilt charger in an electric car application. What you call this is onboard charger. When it comes for motors, you have various types of motor, and you need to select the motors considering your application. So two-wheeler, four-wheeler, and the three-wheeler application. And even in four-wheeler, you have car, you have high-duty vehicles, heavy-duty vehicles, where the requirement of torque is going to be higher. So accordingly, the selection of the motor is also vary considering the applications. So we have two type of motor. One is going to be DC motor and another going to be AC. We have various types in the DC motor. One is brushless and brushed. When it comes for a brush DC motor, we have series wound motor, shunt wound motor, compound wound motor, and permanent magnet motor. And when it comes for a AC motor, you're going to have synchronous or synchronous, can be either single phase or three phase. And the basic function of the electric motor, it provides a torque to the vehicle by using the electric EMF, basically electromagnetic field, and energy is being supplied by the battery, and the torque is controlled by varying the current flow. And this electric motor gives more than 90% efficiency as compared to that of IC engine. And again, this is going to be noiseless. The engine is going to be much more noise than that of electric motor. Still, the researches are going on to reduce the electric motor noise. Uh, but again, the noise in the IC engine is much more higher than that of electric motor. And one more advantage is that the torque going to be higher even at the zero speed. Whereas in the case of IC engine, it needs to run through some RPM to get the required torque. But in the case of electric vehicle, the electric motor is going to provide the torque even at the start of the RPM, which means even at the zero speed, you're going to have a required torque so that it allow the vehicle with a single gear ratio between the motor tire rather than going for a multiple speed transmission. But in the case of uh, the bus application where the torque is much more higher, you go for a multi-speed gearbox. But still, for a car application, for a two-wheeler application, you can have a single ratio gear ratio so that the power gets transmitted. What type of motor is being used for electric car application? So we have seen various electric motor types in the previous slide. So we'll see, are we going with AC or DC for an electric car? So as you know, AC is an alternate current and DC is a direct current. These are the two different types of an electric motor. And the motors are powered by direct current, can be found in an electric vehicle. But only a small mini motors is used for some of the windshield wipers and electric windows application. For example, but not to drive the vehicle itself. For the traction of an electric vehicle, what you're going to use is an alternative current motor used basically. And again, what you also have again two type of motor as I was mentioning. You have synchronous and also the asynchronous motor. In an asynchronous or an induction motor, the rotor is pulled into a spin, constantly trying to catch up the rotating magnetic field which has been created by the stator. And this type of electric car motor is known for its high power output. So when you want to have the high power output, then it's better to go with a synchronous or an induction motor where you're going to experience high power output. Um, and it's been quite selected for its application. And there is one more application where the motor we are going to use is a synchronous motor where this provides high torque at low speed. When you want to have the high torque at a low speed, then you can go for a synchronous motor where the rotor turns at the same speed as that of the magnetic field. And this is good for urban driving. Okay, so if you want to go for urban driving, then this is much more better. Synchronous motor is better. Again, the size is also one of the advantage of the synchronous motor. And a synchronous electric car can also be a compact and also it is good for a low weight application. If you want to have the low weight, then it is also a very good option. So we have seen how does an electric car works. Now let us see how does an electric car motor works. Okay. The electric motor car is built around a set of parts designed to convert the electricity into mechanical energy. That's what electric energy is converted to an mechanical energy with through a creation of a magnetic field. And this electric car motor, it uses initially those that use the direct current motor have quite basic functions. But when it comes for AC application, AC motor, uh, the usage is be much more higher since um, it is known for its type where it will help for meeting the reliability of the complete system itself. And you have the major parts in the electric motor, which is nothing but a stator and a rotor. And the stator is going to be static, and the rotor rotates. And the stator is going to use the energy which is used for creating the magnetic field, and then it will turn the rotor. And the AC motors, it requires the use of conversion circuit transform the direct current, which has been supplied by the battery. And battery in an electric car functions using the direct current. But when it comes to the main motor of an electric vehicle, which needs to provide a traction to the vehicle, this DC energy must be transformed into an AC to an inverter. So that's what the inverter comes into picture. When it comes for a battery pack, we have various types of battery pack, like lead acid battery, lithium ion battery, ultra capacitor, nickel metal hydrates. There are a lot of research is also going on in the various type of battery, like sodium, polymer batteries. Um, but those days, 10 years back, what we have used is a lead acid battery. Now what we are going is with a lithium ion battery. Almost the weight gets reduced three times. And even the energy density, even those things also needs to be considered when you're selecting the battery. And let us see some of the unique application with respect to the lithium ion battery. So they have a high energy per unit mass related to other electrical energy storage system. They also have high power to weight ratio. They also have high energy efficiency. They are having good high temperature performance and low self discharge. And most components of this lithium ion battery can also be recycled, but the cost of the material recovery remains a challenge for the industry. That's what it's not only for this lithium ion, even for any battery, uh, the cost of the material recovery is always a challenge. And there are a lot of startups which is also coming up, even to recycled or recycled electric vehicle components, especially the battery technologies. So again, there are good opportunities for recycling startups as well. And the next battery is going to be the nickel metal hydride battery, and they also offer quite reasonable specific energy and specific power capabilities. And these nickel metal hydride batteries have much longer life than lead acid battery, and they are also safe and abuse tolerant. And these batteries have been widely used in hybrid electric. And the main challenges with the NMH, you call it nickel metal hydride batteries, are the cost is going to be high, and high self discharge and generation is also much more higher at higher temperature. And the need to control loss, hydrogen loss is also one of the biggest challenge basically. That's why it is also uh, loss of hydrogen needs to be controlled. That is also one of the challenges that we need to experience when you're going for a nickel metal hydride batteries. And the golden, the first technology that is coming, that has come up with respect to batteries, lead acid battery, and it is inexpensive and safe and reliable, but you have only the low specific energy, and it is not good for a cold temperature performance. And even this battery is good for commercial application, but for other disadvantages include the low specific energy and also the high weight. and even the performance is also not that much highly efficient as compared to that of the other batteries. And we have the ultra capacitors, which stores the energy in a polarized liquid between an electrode and and an electrolyte. And this ESS, it also increases the liquid surface area. And this ultra capacitor, it can be used for a vehicle as an additional power. Okay, especially when you want to climb the vehicle, climb the hill during the hill climbing, or when you want to have a high acceleration, you can use this ultra capacitor can provide additional power. They can also help to recover the braking energy as well. And this capacitor may also be used as a secondary energy storage devices in an electric vehicle application. And they also help for the electrochemical batteries level, leading to the low power basically. And these are all the architecture of a BMS system, which manages the electronics of a rechargeable battery. Can be either a cell or a battery pack. And this BMS is becoming a crucial factor in ensuring the electric vehicle safety. Um, you can see the BMS, which is lithium-ion battery cell packs. It can be arranged in series, and also in parallel. And it is going to have the microcontroller. It is going to have the BMS system where it gives us an alarm when the temperature or the voltage is going to be higher. The result of that, it is helpful for reducing the uh, stress. Uh, if in case of any fire or any safety related aspects, this BMS will be very much helpful. And you also have some other aspects with respect to the BMS, like temperature sensing or with the help of the microcontroller. If the battery temperature is going to be higher, the battery temperature is going to be 60 or 60. It catches, there is a possibility it may catch fire when the battery temperature is beyond 60 or 60 plus. In that scenario, the BMS will cut off so that uh, the, the opportunity of catching fire is also going to be reduced. And as a result of that, you can ensure that the overall vehicle safety is going to be there with the help of this BMS system. And similarly, when the battery voltage is going to be higher, this will be cutting off uh, the BMS system, and you will not run, means the vehicle will not start basically. And these are the main functions of a BMS, what I have told in short. And this will help for preventing operations, which will result in some of the safety issues basically. And this BMS is also helpful for estimating the battery state of charge and also the state of health during charging and also discharging. And this battery BMS system is also helpful for the cell balancing technology that improves the battery life and also the capacity, thus optimizing the driving range for hybrid electric vehicle and also plug-in hybrid electric vehicle, and even for a complete battery electric vehicle. So this is an inverter, is the important device that converts electricity from the DC to an AC. And because of a solar power system, the power stored by the battery gets charged by the power panel, which is being converted to a standard AC. Uh, by this inverter, it provides the power to plug in outlets and also the other standard devices like 120 volt device. We have a charger, which is very important component in an electric vehicle. And you have two type of charger. One is going to be electric car charger with onboard and also offboard. So onboard charger is the charger which is located and installed in the car itself. And offboard charger is the charger where the charger is not allocated or not installed in the car. And this onboard charger is used to convert the AC supply received from the charge port to the DC supply. and the onboard charger is located and it is installed inside the car, and it also monitors the various battery characteristics and controls the current flowing inside the battery pack. And this onboard chargers will perform these three functions: rectification of the AC voltage from the grid to the DC voltage, and this also controls the current flowing into the battery pack by controlling the DC output voltage. This also communicate with the vehicle of the vehicle equipment. And these are the charging port that you have: AC charging port and DC charging port. Different country is going to use different charging port, different standard basically. You have a different standard basically for charging. The J1772 is one of the standard which is used for the AC charging uh, port, which is used in North America. For Japan, we use J1772, and for the Europe market, we use Type 2 Minacus. And this is what used in most of the Asian countries, China. And you also have the DC charging port, uh, means having different standards like CCS1, CCS2, uh, CHA demo, GB by T. This is what the Europe market, or except Europe market, the Tesla vehicle uses across the world. So this is how the charger looks. This charging port just like acting as an access port for a conventional car. So instead of adding gasoline, it also enables access to the charge port. Both are entry point for an energy storage system into the vehicle. You have the DC-DC converter. As I said, the DC-DC converter is the one which is used to deliver a constant voltage. This DC-DC converter will help the traction battery pack to deliver a constant voltage. But different components of the vehicle has different requirements. This DC-DC converter distributes the output power uh, that is coming from the battery to the required level. So if in case if the output power is going to be much more higher, it will try to deliver the constant voltage or constant power, or whatever the level it is required. And it also provides the voltage required to charge the auxiliary battery. You also have the auxiliary battery, which is an additional battery. And in order to provide the voltage to charge the auxiliary battery, this DC-DC converter is used such a device. You have the controller. This power electronic controller determines the working of electric car, or it's not only car, even for other application as well. It performs the regulation of the electric energy from the battery's electric motor. The pedal set by the driver determines the speed of the car, and the frequency of the variation of the voltage that is an input to the motor. It also controls the torque produced. In brief, this controller, it manages the flow of electrical energy which has been delivered by the traction battery, controlling the speed of electric traction motor and the torque it produces. And this component is a good one to determine how the electric car works. You have the transmission, which is a very important component. The purpose of the transmission is to transfer the mechanical power from the electric motor to the wheel to a gearbox. You have various gearbox. So the one what I have shown is for a heavy duty vehicle, like it can be used for electric bus application. Because for when you're going for electric bus application, or for a truck application, you need to have the high torque, for which you need to have the multi-speed transmission. Whereas in the case of the two-wheeler or even for a car application, you don't need to have the multi-speed. You can have a single gear ratio where it will meet the required torque level. The very another challenge is the thermal cooling system of a battery. Okay. So this is one of the challenges. You can see the line diagram here. The outside vehicle is going to have the high atmospheric heat. So heat is absorbed from the atmosphere here, and second one is this heat is compressed and turned into heating. You can see that temperature is getting higher here, and this heats cold air in the cabin and it raises the temperature. And the fourth point here is the heated air is blown into the cabin. And the fifth one, this is the fifth one where we are going to decompress the heat, which it turns into a low temperature heat. You are going to use the cold air here and you are going to cool it. And this is the architecture of a bus application where you have different type of charging, AC charging, DC charging, and DC flash charging. You have the flexibility for any type of charging. So this is the one which is being used for some of the bus application like the Ashok Leyland bus application. Um, and you also have the lithium ion battery with nickel metal hydride carbide having 650 volts volt DC link. And as I said, you are going for a multi-speed gearbox since the torque is going to be much more higher. And you also have the auxiliary inverter, BCU, vehicle control unit. You also have the auxiliary devices like HVAC, steering pump, and also the compressor. And this DC-DC converter, what I was telling you, DC-DC converter, it also used for charging the auxiliaries, uh, power to the auxiliaries. When I say auxiliaries, it involves HVAC, steering, and also the compressor, and even the, the auxiliary batteries, whatever you are going to use. And this DC-DC power has been converter is very much useful in those applications as well. In the case of electric vehicle bus charging system, so you have various type of charging. Where you can go for overhead line charging or plug-in hybrid plug-in charging, or even with the help of pantograph you can charge the vehicle, or even you can go for a induction type where it's a non-contact charging where we are going to pass the current to the primary coil, and electromagnetic field is being induced that will be used for charging your battery. This is some of the electric vehicle architecture for a two-wheeler application. You can see the battery. You also have the bidirectional converter, DC-DC converter, uh, one for going for the, the motor application with the help of an inverter where it converts DC to AC, and this motor converts the electric energy to mechanical energy such a way the vehicle will be moving. And you also have the DC-DC converter, which is also used for charging your auxiliaries. Like it can help you with 12 volts or 48 volts auxiliary supply. In the case of a two-wheeler application, you can have some auxiliary charging supply. And the one what I was telling is a regenerative braking that is quite often used even in two-wheeler and also car application. Where in the case of regenerative braking, when you are applying the brake, the mechanical energy uh, from the wheel is gets converted to electric energy. Here, the motor acts as a generator during the regenerative braking, and then power which is going to the battery or the electricity is used for charging the battery, and that is again reused during the vehicle operation. And it's very important that the integration area is very much important in the electric vehicle. These are the various parts. So what we have seen is very quite simple parts, but yeah, it's very important that how we are going to integrate. So we have a lot of parts like suspension parts, brake parts, steering parts, driveline, powertrain, HVAC, body control system, and the electrical systems and interior systems. So you have various systems, and how you are going to integrate that with respect to the safety aspects, weight aspects, dimensions aspects, ergonomic aspects, energy aspects, performance aspects, validation aspects, regulation aspects, change management aspects, benchmark aspects. So all these things you need to integrate. That's where the challenges lies, and also the opportunities also lies. It's not just challenges alone. Even you have a lot of opportunities. With the help of the system integration, you can also reduce the uh, weight, you can also increase the safety of the vehicle. You can have the optimum design. You can have better ergonomics. You can use the better energy storage system. You can also increase the performance of the vehicle. You can increase the durability of the vehicle, the reliability of the vehicle, and use the better regulation system. So when you say that you change management, suppose if you're changing the supplier of battery from one X to Y, or if you're changing the electric motor, if you're changing the type of the electric motor, or if you're changing the supplier of the electric motor, so there are a lot of opportunity as well to reduce the cost at the same time to also to improve the performance at the same time to also reduce the defects basically. Even you can even we have benchmarking area where you can do some benchmark. So there are a lot of competitors. Let's say for example, when you take the two wheeler, you have a lot of players like Hero Motorcorp, Hero Electric, Okaya, and you have the Ether, you have lot of two-wheeler application, Ola, S1, S1 Pro. So you have various competitor among two-wheeler itself, and similarly for a four-wheeler application, is used by Mahindra, Tata, Hyundai, Ford. So you have a lot of competition among the two-wheeler segment, four-wheeler segments, electric bus segments. When you do the benchmark, you will also come up with some improvement areas with respect to all these parameters like safety, weight, or the design, or ergonomics, or energy storage system, the performance aspects with respect to all these systems. Basically, this is giving you a scope of an improvement and also an opportunity, rather than I can say it's not a challenge. And to sum up what we have seen so far and what is a way forward, so we are going to have a different unique category technologies which are coming up into the market, and there are many being in process, and also it's been proposed, and it's also in research stage. In the upcoming 1 to 2 years, there will be a lot of various design. Smooth transition will take place to the architecture, and also you are going to have a better solution which will have a sensible architecture for your electric vehicle. And this electric vehicle architecture is also a seamless integration of various futuristic technologies, and it also requires a special attention when going for a design and need to test and also to validate in various cases. Testing and validation is also one of the very important thing when it comes for an electric vehicle. You need to do a lot of testing with respect to the vehicle. We need to test it in city condition, rough road condition, city with highway condition, and we also need to do a lot of component level test, like the test what we are going for a vibration test, noise vibration, NVH test. But noise is not a criteria here because noise is less in electric vehicle, but vibration is also needs to be considered. You also need to run the different tests. Basically, you need to validate it to ensure that there is no failure going to happen for your components, electric vehicle components, which involves battery, electric motor, and you do a lot of powertrain test also, like motor bench test. You do the performance test, power rating test. So all these tests you need to do it and you need to validate it. And as a result of that, after that, you try to launch the vehicle. Maybe after extensive testing that you are going to do at the component level and also on the vehicle level. Thank you. Thanks for an opportunity. Once again, I thank AKGEC for this opportunity. I can be contacted at P.Arjunraj@gmail.com, and my mobile number is 8778983428.